Hello, good evening to all of you, Mansi, Radhika, Shayamsh, Akshay. In continuation with the last class, yes, good evening, good evening. In continuation with the last class, I would like to continue or to start with the properties of aldehydes and ketones. So, I have already told you that the properties Bapanapalli, Kashyap, yes, the properties of aldehydes are studied under the following heads: addition reactions, number 2, addition elimination reaction, this is also called condensation reaction, then third one, oxidation of aldehydes and ketones, fourth one, reduction of aldehydes and ketones, and then special properties, addition reactions, addition elimination is also called condensation reaction, oxidation of aldehydes and ketones, reduction of aldehydes and ketones, and then special properties. I would like to deal with just one or two maximum examples for addition and addition elimination reactions. We shall not go deep into Radhika, why boiling points of aldehydes and ketones are high? Remember, inorganic compounds, NaCl has got the melting point of approximately 800 degrees Celsius. Metals have got very high melting point, except alkali metals. Sodium has got the melting point of just 98 degrees, and as you go down the melting point decreases. The ionic compounds will have very high melting point and boiling point. Even in aldehydes, even in organic compounds, if you have polarity in the molecule or hydrogen bond, then yes, Soham Rastagi has given the answer. Due to polarity in a molecule, C double bond O, it is polar, minus and plus. Two reasons: number one, oxygen is electronegative, and number two, there is mobile pi electron. Therefore, they will have higher boiling point. But sometimes alcohols will have higher boiling point than aldehydes because of association due to intermolecular hydrogen bond. Okay? Thank you, Rastagi. Yes. Now, we shall see the addition reactions, a few addition reactions. Which are the addition reactions we have to study? Addition of hydrogen cyanide. You may or may not be knowing that HCN, yes, Akshay, hydrogen bond, that is for alcohols. Hydrogen cyanide is unstable. It is obtained from NaCN. So, here is a question before I go to the question most students not got wrong from the last CPP. The question is, we cannot prepare benzaldehyde starting from benzene and acetophenone, benzene and toluene, benzyl chloride and benzol chloride, benzyl alcohol and styrene. Okay, thank you. Answer is A, because benzene with CO and HCl in presence of AlCl3 will give benzaldehyde. Toluene on Etors reaction gives benzaldehyde. This with Rosenmund's reduction will give benzaldehyde. This when heated with sodium hydroxide will give benzaldehyde. This on oxidation by PCC will give benzaldehyde. This on ozonolysis will give benzaldehyde. So, B, C and D give benzaldehyde, whereas A only benzene can give by Gotterman-Koch reaction, but C6H5COCH3 cannot directly give benzaldehyde. Acetophenone will not give benzaldehyde. Therefore, the answer is A. Even though one will give, another will not give. Okay, right. So, HCN is unstable. This HCN, so properties of aldehydes and ketones, that is the goal for today, which I have already told you. So, addition reactions, HCN is not a stable compound. Under can you say that maximum surface area, maximum is the boiling point, minimum number of alkyl groups increase the boiling point, that hydrocarbon increases. See, you know that straight chain compounds will always have higher boiling point. That is what the first part of your answer say. As the number of alkyl groups increase, boiling point will also increase. Certainly, as the molecular weight increases, boiling point will also increase. That is why, see, methane is a gas. C8H18 is a liquid. C15H32 is a thick liquid, diesel, whereas C22H46 is candle wax, solid. So, as the molecular weight increases, the boiling point, melting point will also increase. Okay, you have already given the answer for that. Yes, addition reaction HCN is unstable. It is always obtained by mixing NaCN plus HCl. Add HCl means adding NaCN and HCl. Just like alcohol reacts with PBr3, reacts with PCl3, but it does not react with Pi3 because Pi3 is not available readily. Therefore, OOH is heated with phosphorus and iodine. So, similarly, HCN is also the same thing. So, HCN so, if you treat an aldehyde or a ketone, I will take just one example. This is nucleophilic addition. So, HCN, it will give R, CH, OH and CN. I will make it more clear and easy for you. I will make it easy for you. During addition reactions, please note, during addition reaction to aldehydes and ketones, if H is there, H will add on to oxygen, remaining group adds on to carbon. H will add on to oxygen, the remaining group adds on to carbon. Any addition reaction you consider, same thing. Similarly, with ketones, or COR dash plus HCN will give or CR dash OH and CN, cyanohydrin. Okay. As I said, just one is enough for us. The remaining addition reactions are addition of sodium bisulfite, which gives aldehyde sodium bisulfite or ketone bisulfite, which are white crystalline solids, and sodium bisulfite is used to separate and to purify aldehydes and ketones. So, this is just a glimpse of the addition reaction. The next one is addition elimination reaction. See, RCHO plus ammonia or CHO, ketone plus ammonia. I have told you H adds on to oxygen, remaining group adds on to carbon, therefore you get R CH OH NH2. This on heating undergoes dehydration, resulting in the formation of RCH double bond NH and imine, is obtained. So, this is addition elimination. First addition takes place, later water is eliminated, water is removed. This is elimination reaction. The second part is elimination. For elimination reactions, we have a series of this addition elimination reaction, we have a series of reactions, all of them take place like this only. H adds on to O, remaining group adds on to carbon, later dehydration takes place. Similarly, for ketones also, suppose you have a ketone, the final product. So, this will form OH and NH2, then H2O will be removed. So, you get RCR double bond NH, again an imine is obtained, dialkyl imine is obtained. So, this is addition of ammonia. Now, similar to this, we have addition elimination reaction of RNH2, alkyl imine is obtained. Addition elimination of hydrazine, which gives hydrazone. Addition elimination of NH2OH, hydroxylamine, it results in the formation of oxime. Addition elimination of phenyl hydrazine will give phenyl hydrazone. Addition elimination of 2,4-dinitrophenyl hydrazone, phenyl hydrazine will give phenyl hydrazone, and then semicarbazide. I repeat the names: addition elimination with amines, with hydrazine, with hydroxylamine, with phenyl hydrazine, with 2,4-DNP and semicarbazide. Addition, H adds on to oxygen, remaining group adds on to carbon. Then elimination. What are the products obtained? Here you get alkyl imine. Here you get hydrazone. Hydrazone. Can elimination take place without heating? See, Akshay, it's a good question. If the groups that are present are bulky, usually they undergo dehydration very easily at room temperature or slightly above, but in the case of aliphatic aldehydes, you have to heat it, then only the dehydration takes place. Elimination, dehydration. It is addition elimination reaction, which is also called condensation reaction. Did you follow, Akshay? Okay. So, this will give hydrazone, this will give oxime, this will give phenyl hydrazone, phenyl hydrazone. This will give 2,4-dinitro phenyl hydrazone. This will give semicarbazone, semicarbazone. Yes sir, okay, fine. Semicarbazone. Out of these addition elimination reactions, now I would like to explain the DNP reaction, because this is a test for aldehydes and ketones. This is a test for aldehydes and ketones. So, okay, how do you test it? Now, we will write the equation for an aldehyde. Similarly, for a ketone, RCHO plus NH2 NH NO2 NO2. This is 2,4-DNP. Addition elimination, the reaction will take place like this. H2O will be removed in toto. So, it results in the formation of RCH double bond NH NO2 and NO2, 2,4-DNP NH. This is from an aldehyde. If it is ketone, it will be R dash double bond NH. The rest of the group will be repeated, NO2 and NO2, ortho and para, 2 and 4. These two obtained from aldehydes and ketones are orange, beautiful orange, yellow crystalline solid, orange, yellow crystalline solid. So, aldehydes and ketones, if you add 2,4-DNP and just shake it at room temperature, laboratory temperature itself, it will give aldehyde 2,4-dinitrophenylhydrazone or ketone 2,4-dinitrophenylhydrazone. Both are orange, yellow crystalline solid. So, this is a test. Okay. The next one, now we start with some important reactions with names. This reaction is called Haloform reaction, even though it is Hydrofarm. Haloform reaction. What is this haloform reaction? Preparation of or chloroform, preparation of bromoform or preparation of hydroform is called haloform reaction. What are the reagents and reactants required for this? So, the compounds that undergo haloform reactions are ethanol, ethanal, propan 2-all, CH3 COCH3, propanone, C6H5 COCH3. So, these are the compounds which undergo haloform reactions. What do you mean by haloform reaction? You take any of these compounds, ethanol, ethanal, propan 2-all, propanone, restophenone, that is ketone should have COCH3 group. If it is a ketone, it should be a methyl ketone. Take these compounds, you heat it with a halogen and an alkali, that is all. So, take any of these compounds, you heat it with a halogen and an alkali, you get the respective haloform. If the halogen is chlorine, you get chloroform. If the halogen is bromine, you get bromoform. If the halogen is iodine, iodoform. Among these, iodoform is the most popular reaction because it gives yellow crystalline solid. Therefore, we study the haloform reaction. Under haloform reaction, we study only iodoform reaction. Here is one such reaction. When propanone does propanol? No, propanol will not give propan 2-all, Radhika, propan 2-all, because that undergoes oxidation to methyl ketone. Propan 2-all, you already know that a secondary alcohol on oxidation gives a ketone and it gives methyl ketone, therefore, that will answer. The first will not answer. Propan 1-all will not answer the test. Only propan 2-all answers the test. Okay? Now, you are going to heat propanone with sodium hydroxide and iodine. The reaction will be like this. NaOH with iodine will give sodium iodide and sodium hypoiodide. Sodium hypoiodide. Acetone or propanone reacts with sodium hypoiodide, forming triiodoacetone. Triiodoacetone. This triiodoacetone reacts with sodium hydroxide, giving iodoform. And then CH3COONA. Then why does ethanol gives this? Ethanol will give CH3, CH2. The molecular weight is less. This undergoes CH3CHO. So, this CH3CHO can easily undergo CCl3CHO chlorination very easily, whereas CH3 CH2 CH2OH, if it undergoes chlorination here, it is of no use, whereas ethanal with CCl3CHO will give, with chlorine will give this. This will react with an alkali like sodium hydroxide, giving CHCl3. So, oxidation, propanol, even this is oxidized, further chlorination will not take place. Therefore, it will not, the reaction will not take place, it is not answered. So, you get CHI3. Suppose, see, it is very easy to remember this Hydrofarm or Haloform reaction. So, instead of using sodium hydroxide and this, you can use calcium hydroxide and chlorine, you get chloroform, CHCl3, chloroform is obtained. Same type of reaction will continue, chloroform, calcium hydroxide and chlorine, it will give chloroform. Now, the main thing you have to remember in Hydrofarm or Haloform reaction is, so I will write it. Suppose you have a compound of this type, you have a methyl ketone. This methyl ketone, this is methyl ketone. If you heat it with sodium hydroxide and iodine, if you heat it with sodium hydroxide and iodine, it will give CHI3, yellow crystals of iodoform. Okay, fine. How to write the other product? See, ketone may be any complicated ketone whose structure we do not know, but it contains methyl CO. That is all. Then the thing is, from COCH3, this carbon atom will come out as CHI3. The rest will form COONA, that is all. You give any compound you want. Iodoform reaction, can't we take homologous of those compounds? No, not possible, because one is a primary alcohol, another is secondary alcohol, etc. Not possible. The homologous series, it will apply to first alcohol, ethanol, not for others. Okay. So, in iodoform reaction, what you have to remember is, see, in acetone, this CH3 will come out as CHI3, the remaining will be COONA, that is all. So, while writing the iodoform reaction, whatever may be the ketone, it should be a methyl ketone, methyl group will come out as iodoform, the rest ONA will be added on, ONA will be added on. This is iodoform reaction. Similarly, chloroform and bromoform reactions. Okay, fine. So, this is a special reaction of aldehydes, that too ethanal, not others. Benzaldehyde will not answer this test. Ethanal, because chlorination can easily take place, and methyl ketones. Okay. Now, I will explain with one more example. Suppose we have COCH3. I have told you, if you heat it with sodium hydroxide and iodine, this will come out as CHI3, the rest will be the sodium salt, that is all, COONA. Any ketone, methyl ketone, the reaction will be like this. It is an important reaction, and this is a test used, this is a reaction used to test methyl ketones and ethanal. Okay, right. The next one, same reaction, iodoform reaction with ethanal. See here, ethanal CH3 will come out as CHI3, the rest HCOO-Na. One carbon atom will be left over, you get HCOO-Na. If it is chlorine, you get CCl3CHO, and here you get CHCl3, chloroform. Okay, right. The next. Now, reduction of aldehydes and ketones. Reduction of aldehydes and ketones. I have taken a representative aldehyde. This is croton aldehyde, croto, not N, N is absent, croton aldehyde. Reduction of an aldehyde can be carried out by different methods. Here I have given you a comparison. Suppose you use lithium aluminum hydride along with water. Lithium aluminum hydride is a good reducing agent for aldehyde to become CH2OH. So, this will convert CHO into CH2OH. Specific. It is nothing to do with the double bond. So, double bond will not change. So, if it is unsaturated aldehyde, you get unsaturated primary alcohol. Unsaturated primary alcohol. Suppose you use sodium borohydride for this. It has got the capacity to reduce aldehyde into alcohol. So, sodium borohydride, it can reduce aldehyde into a primary alcohol. At the same time, it can reduce CH double bond CH into CH2 CH2. It has the capacity to reduce the double bond as well as CHO. Therefore, you get a mixture. So, double bond only CHO can be oxidized or CH double bond CH2. Therefore, you get a mixture of these two. Lithium aluminum hydride is very specific, reduces aldehyde, whereas sodium borohydride reduces primary aldehyde into primary alcohol, at the same time double bond into single bond. Whereas, if you heat this with hydrogen gas in presence of nickel, it will certainly reduce both of them. Certainly reduce double bond as well as aldehyde simultaneously to form a primary alcohol, saturated primary alcohol. So, these are the things which you should remember clearly while answering multiple choice questions. Lithium aluminum hydride reduces only aldehyde. Sodium borohydride can do, but it gives a mixture, whereas nickel, hydrogen in presence of nickel, both of them will be reduced and you get only one product. So, this is comparison of the reduction of aldehydes, and you know that ketones on reduction give secondary alcohols. Ketones on reduction give secondary alcohols. See, one more example has been given. Since it is aromatic, borohydride, the reaction is very slow. Very slow because it gives rise to a mixture of the two things, unsaturated primary alcohol and saturated primary alcohol, whereas with lithium aluminum hydride you get this, which is best reducing agent. Akshay, it depends upon what compound you want to reduce. Do you want to reduce only aldehyde, use lithium aluminum hydride. You want to reduce both of them directly, use hydrogen gas in presence of nickel. If you want mixture, I want to retain the double bond, at the same time I want which we can apply anywhere. Usually this is common, that is why I have given you this comparison of the reduction properties. So, reduction of aldehydes into primary alcohols with double bond, yes. Here is an oxidation reaction, special oxidation reaction with selenium dioxide. Here selenium dioxide oxidizes alpha carbon having hydrogen to aldehyde. Suppose you have an aldehyde group and you have CH3 group, alpha hydrogen CH3, then it becomes CHO. So, CH3CHO, selenium dioxide, that is sir, what is power alcohol? See, power alcohol, Radhika, power alcohol is petrol with 5 to 8 or up to 10% ethanol is called power alcohol. See, Brazil is the country which uses this mixture to save petrol. In our country, there was a rumor and probably the decision was made to add alcohol to petrol, but we haven't done it till today. The power alcohol is petrol about 10, in Brazil they may go up to I think 12% of alcohol. This mixture is called power alcohol to save petrol. Okay, right. So, here is a special oxidation. Already you have an aldehyde group or a ketonic group that will be oxidized. The alpha hydrogen atom, the carbon atom having alpha hydrogen atom gets oxidized to an aldehyde group. So, acetaldehyde or ethanal, this is ethanal, will give glyoxal or ethane dial, ethane dial. See, purposely I have taken some of the reactions which are not so common in your textbooks. Okay? So, selenium dioxide is specific oxidation alpha hydrogen atom into CHO group. One more example is here, CH3COCH3 acetone or propanone. If it is oxidized by Se selenium dioxide, see, CH3 becomes CHO, CH3CO CHO, methyl glyoxal, methyl glyoxal, a special oxidation reaction. Okay, right. So, before I take up these ones, I would like to explain the reduction, special reductions. I gave you the reduction of aldehyde by lithium aluminum hydride, sodium borohydride, then hydrogen in presence of nickel. Somebody has asked, Kashyap, you have asked for palladium, to a little extent okay, palladium, but in the case of aldehyde nickel is a better one. And then Okay, I will come to that. Kashyap. K2CR1 is the best oxidizing agent which can be applied anywhere. Akshay. For Akshay, K2CR2 it can be used for alcohols to form aldehyde if you distill it. If you heat it for a longer time, it forms carboxylic acid. See, CH3, CH2OH with potassium dichromate and sulfuric acid. If you distill the mixture, ethanol will distill over. If you do not distill, if you heat it, it results in a formation of carboxylic acid. But KMnO4 is better oxidizing agent than potassium dichromate. Akshay, I think you followed. Okay, Kashyap, what's the octane number? See, the efficiency of petrol depends upon, petrol is a mixture of isooctane with very little quantity of heptane. If the heptane percentage is more and more, efficiency of petrol will come down. Depending upon that, we have the octane number. Let us say octane number is 94 octane, which means petrol will have the efficiency of having 94% of isooctane and the rest is heptane. That is called the octane number. Kashyap. Okay, right. Coming to special reduction. Special reduction. This is called Clemmensen reduction. Clemmensen reduction, important. You take ethanal, you reduce by zinc amalgam and concentrated HCl, important, concentrated HCl, very important. Contest, I will come to that. Contest, I will explain this. Okay, the contest question, there is lot of problems are there in previous class contest question. Ebonite is highly vulcanized rubber. It contains about 50% of sulfur. That's called ebonite. Answer is C. The winner is Smarnika. You know that one session will be added to you, Smarnika. Okay. So today's contest time. Benzene undergoes Gottman-Koch reaction. Benzene undergoes Gottman-Koch reaction with CO and HCl in presence of AlCl3 to form A undergoes aldol condensation with CH3CHO and then undergoes dehydration to form B. B when heated with Tollen's reagent forms C. C when heated with soda lime gives D. What is D? This is the contest time. Question for the contest time. There are so many properties of aldehydes and ketones to be answered. So answer has been already given on C. Answer says answer is D. Okay. Today's so properties of aldehydes and properties of ketones. Few properties are over. I will take up the remaining important properties tomorrow 4:30. Okay. Thank you for joining us. Again, get the passport. Get access to the class practice packs sent by me with the passport. Thank you. You have asked so many questions today. I think I have given you the answers. You asked me more number of questions, especially on aldehydes and ketones. If you ask me, you will get to know more and more about aldehydes and ketones. It's a huge chapter. Okay, right. Thank you.